How to improve insert-per-second performance of SQLite Introduction. SQLite is a lightweight and fast embedded database. However, beginners often notice that large numbers of insert operations can become slow. A very common SQLite optimization question is, how can you improve insert-per-second performance in SQLite? This topic explains why SQLite inserts become slow, transaction overhead, batch inserts, WAL mode, prepared statements, PRAGMA optimizations, index impact, disk I/O considerations, real-world optimization techniques, common mistakes, best practices. This is a very important database performance topic. Why SQLite inserts become slow? By default, SQLite prioritizes curse, reliability, consistency, crash safety. Every individual insert may trigger transaction handling, disk synchronization, journal writes. Example of slow approach. Insert into user's name, values John. Insert into user's name, values Alice. Insert into user's name, values Bob. If each statement runs separately, X. SQLite performs many disk sync operations. Performance becomes very slow. Biggest performance improvement. Transactions. The most important optimization is wrapping multiple inserts inside a single transaction. Slow example. Insert into logs, message, values A. Insert into logs, message, values B. Insert into logs, message, values C. Each statement commits separately. Very slow. Fast example using transaction. Begin transaction. Insert into logs, message, values A. Insert into logs, message, values B. Insert into logs, message, values C. Commit. Huge performance improvement. Why transactions improve performance? Without transaction batching. Insert, disk, sync. Insert, disk, sync. With batching. Begin transaction. Many inserts. Single disk sync. Commit. Fewer disk writes equals much faster. Use prepared statements. Prepared statements avoid repeated SQL parsing. Slow example, SQLite 3 exec, db, insert into users, name values John, 0, 0, 0. Repeated parsing is expensive. Fast example, SQLite 3 stemmet, stemmet. SQLite 3 prepare v2, db, insert into users name values, -1, and stmet, n. 4. Int I equals 0, I equals 1000, I++. SQLite 3 binds text, stmt, 1, John, -1, SQLite static. SQLite 3 step, stm8. SQLite 3 reset, stmn. SQLite 3 finalize, stmt. Benefits. Reusable execution plan. Reduced parsing overhead. Faster inserts. Enable WAL mode. SQLite supports WAL, write-ahead logging. WAL improves concurrent performance and insert speed. Enable WAL, PRAGMA journal mode equals WAL. Benefits. Check. Faster writes. Better concurrency. Reduced locking contention. Adjust synchronous mode. SQLite uses synchronization for crash safety. Default is safer but slower. Faster setting. PRAGMA synchronous equals normal or even. PRAGMA synchronous equals off. Trade-off mode, speed, safety. Full, safest, slowest, normal. Balanced, faster, off, fastest, riskier. Synchronous equals off. Can lose data during crashes. Use carefully. Disable indexes during bulk inserts. Indexes slow down inserts because they must update for every row. Slow scenario. Insert row. Update indexes. Write to disk. Faster bulk insert strategy. Drop indexes. Insert data. Recreate indexes. Example. Drop index IDX user's name. After inserts. Create index IDX user's name on users. Useful for large imports, ETL jobs, migrations. Use multi-row inserts instead of many separate insert statements. Slower insert into users, name, values A. Insert into users, name, values B. Insert into users, name, values C. Faster. Insert into users, name, values A. Reduces SQL execution overhead. Avoid auto-commit mode. SQLite automatically commits every statement if no transaction exists. Auto-commit causes many disk syncs, lower throughput. Always batch inserts manually. Use memory temp storage for temporary structures. PRAGMA temp store equals memory. Can improve performance. Increase cache size. SQLite cache tuning may help. Example. PRAGMA cache size equals 1000. Larger cache. Check. Reduces disk reads. Improves throughput. Real-world example. Bulk log ingestion system. Without optimization. 500 inserts per second. After. Transaction batching. Prepared statements. WAL mode. Performance may increase dramatically. Common beginner mistakes. 1. Inserting without transactions. Biggest performance killer. 2. Recreating statements repeatedly. Repeated SQL parsing slows execution. 3. Too many indexes. Every index increases insert cost. 4. Using full sync for temporary data. Unnecessary overhead. 5. Ignoring WAL mode. Default journal mode may reduce performance. Performance optimization flow. Use transactions. Use prepared statements. Enable WAL. Reduce indexes. Tune PRAGMA settings. Increase throughput. Example, high-speed bulk insert in SQLite 3 exec. DB. Begin transaction. 0, 0, 0. SQLite 3 statement. SQLite 3 prepare v2, DB. Insert into user's name, values, -1 and stamped, null. For int I equals 0, I equals 100,000, I++. SQLite 3 bind text, statement 1, John, -1, SQLite static. SQLite T step, statement. SQLite 3 reset, statement. SQLite 3 finalize statement. SQLite 3 exec, DB, commit, 0, 0, 0. This is a common high-performance pattern. Best practices. Batch inserts inside transactions. Use prepared statements. Minimize indexes during bulk load. Enable WAL mode. Tune synchronous mode carefully. Reuse statements. Optimize disk I/O when high safety matters. Use safer settings when handling. Check. Financial data. Check. Medical systems. Check. Critical production systems. Prefer. PRAGMA synchronous equals full, even if slower. Simple definition. Improving SQLite insert performance means reducing disk synchronization overhead and minimizing repeated SQL execution costs. Final summary. SQLite insert performance is mainly affected by transactions, disk synchronization, statement parsing, indexes, journaling mode. Most important optimization. Use transactions plus prepared statements. Key idea. SQLite becomes extremely fast when inserts are batched efficiently.